Good evening, everyone. I'm delighted to see this room packed like this. This is fantastic. What do you think, Ravi and RF? This is awesome. My name is Kiran Malhotra. I'm the Executive Director for TiE Silicon Valley. We have a fantastic program for you tonight. I'm sure you already know that. Before we start any program, I like to do what I call the TiE overview, just to give you context about what we do and who we are and why we are. Before I do that, I'd like to see how many of you have ever attended a TiE event in the past. Practically all of you. How many of you have not attended a TiE event? Oh, that's great. Okay, so, and how many of you are members? Non-members? Great. Patricia. 30 cents a day, folks, for membership at TiE Silicon Valley. You get to come to 50 plus events just like this one and our huge conference, TiECon, which I will mention later. We were founded right here in the Silicon Valley in 1992 by a group of entrepreneurs who came to this region from the Indus region, and they became very successful, and they said, you know what, we didn't have a lot of help when we did this. We would like to come together and give back to the entrepreneurial community and help other people succeed. So that's exactly what they did. They would come together on a monthly basis. They would bring other entrepreneurs who were successful at that time. And before we knew it, we grew into 57 chapters in 14 countries with the mother chapter here in the Silicon Valley. We have a global membership of 14,000 members worldwide of these 57 chapters. At TiE, we have 4 major stakeholders. We have our general members, which many of you are general members. We have our charter members. Our charter members are highly accomplished entrepreneurs, they're highly accomplished corporate executives or academics, and they're invited to be part of this community, and they are invited because we want of them the very, very important asset, and that's their time and their intellectual capital. And so they actually paid to become charter members, and they pay me so that I can get access to, and you can get access to their intellectual capital and their experience. And they do so freely. They're the ones who design these programs, put them together, and are on our board of directors. And I'd like to see a showing of all the CMs in the room today, all the charter members. There's quite a few of you. So all of you take a good look. Raise your hands really high, charter members. Take a good look at these guys and go and sit next to one of them or 2 of them and get to know them, because I assure you, you will make a friend, you will meet a colleague, and you will expand your network tenfold by talking to any one of these people. Our third category of stakeholder are our sponsor community. If the charter members are the backbone, the sponsors are the lifeblood of TiE. There is no way that we could do these programs without their generous support. We have sponsors from all categories, from the VCs, to the large corporations, to banks, service providers, law firms, and we thank the sponsors for their very, very generous support of TiE. We couldn't do these programs without your support. Thank you to all the sponsors who are in the audience today. And then I mentioned a 4th category, and the 4th category is made up of all these 3 categories, and that's our volunteer community. Everybody who is part of this group, whether it's the speakers, the people that you see at the door, the people who organize these things, TiECon, our board of directors, except for the small staff that we have a volunteer army of 500 people who make this organization work. And so all of you who have volunteered for TiE, all of you who are speaking today, we thank you, because we certainly couldn't do the quality of the programs and the things that we do without that support. As I mentioned, we have a whole bunch of different programs that we do. We have forums, we have our special interest groups, we have our TiE Institute, we have our networking mixers, and we have a program that we started about a year ago called TiE Angels. How many of you are entrepreneurs starting up something and looking for a little bit of seed funding? There's a lot of hand raising this evening. That's it? Just one? In a room full of entrepreneurs? Well then, you're the ones who will be interested in TiE Angels. We have funded 10 companies to date to about $4 million, and it's very simple to go online and fill out the application. And if you have any questions about that process, you can go ahead and contact me. But we also have some steering committee members in the room. Can you raise your hands? Or just, yeah, a couple of them. If you have any questions about TiE Angels, feel free to talk to any of them as well. I do want to mention TiECon. And I'm particularly, I always like to tout TiECon because it's the world's largest conference for entrepreneurs. Our next conference is going to be May 18th and 19th right across the street at the Santa Clara Convention Center. But I'm very excited about it today because I just found out that we were in Worth magazine listed as the 10 best conferences for ideas and entrepreneurship, and we were listed number 7 right underneath TED, and guess what? The World Economic Conference was listed at number 10. So TiECon was above the World Economic Conference. So if you have not been to TiECon, I guarantee you that it'll be it showcases the best of TiE and all of TiE. It's one of these kinds of programs and networking and just a lot of fun, a lot of buzz in a larger scale. We attract about 4,000 people, and it's just a fantastic conference. You can go to TiECon.org to check out this year's wrap-up and this year's conference, and we will start marketing the conference in a few more months. Lastly, I would like to thank my wonderful staff and my wonderful board of directors for all of the things that they do. I forgot to point out in the beginning some very significant charter members who are my board of directors. Vish Mishra, president, he's sitting here. If you don't know him, you should get to know him. Naveen Bisht, our program chair, and Murli Rangarajan. Where is Murli? Our membership chair, and Sanjay Mittal was here too, right? Our systems chair. Oh, Paul Singh, our marketing chair. It's hard to see your blue turban, Paul. Thank you all very, very much for the support. Both the staff and the board of directors. It's wonderful to work in such a dynamic organization. So that's it for me. I am going to now introduce our host for the evening, Arif Jan Mohammed. Arif is a partner at Lightspeed Venture Partners. Lightspeed has been a long-time supporter and sponsor of TiE, and I'm going to turn it over to him for the evening. Thanks for your attention.
All right, great. Thank you, Kieran, and thank you to the TiE leadership for pulling this together. As Kieran said, my name is Arif Jan Mohammed. I'm a partner at Lightspeed Venture Partners. Very quick overview. We are an early-stage venture capital firm based out of Menlo Park with offices in Israel, India, and China. We manage about $2 billion in capital. We're investing out of an $800 million fund that we raised a few years ago, doing a lot of work in the big data space, and I know a lot of these people on the panel. Super excited about big data and the promise that this theme actually does hold for the future. We've made a few investments in this space, MapR Technologies, DataStax, as well as EdgeSpring, and we're looking for more. So afterwards, please do come and talk to me. With that, I'd like to introduce TM Ravi, four-time serial entrepreneur. He most recently co-founded, built, and then sold Mimosa Systems, which was a great exit all around. He's, as Vish would put it, probably the coolest nerd that you will ever meet. So with that, I'd like to bring on Ravi up.
Thank you. Great. So what we'll do today, we have 2 hours, and traditionally the way this works is you have sort of people discussing for an hour and 15 minutes, and then you have the Q&A. And so I thought instead this time we'll mix it up, because by the time it comes Q&A, everyone's beat and they want to go home, and so we kind of ended it. So we'll kind of mix it up and hopefully make it more stimulating. And so the one challenge with this area of big data is it's kind of an area that's relatively new. And there's a lot of people who don't know what big data is all about, but they're sort of jazzed with all the hype. So what we thought we would do is spend the first portion, 10, 15, 20 minutes, just being a little more, knowledge transfer and information as to what is it why big data, what is big data. There's a technology stack that's commonly associated with big data called Hadoop. So motivating all of that so that we're all on the same page. And then we'll get to the sort of the action. And there is kind of another audience. I didn't see a lot of people say, I want to start a company, probably because they're in other companies and don't want their friends to know. So there's a whole audience who wants to know what are the opportunities around Hadoop, where do we start a company, and so we hope to cover some of that. And for the people who are practitioners in Hadoop, there's going to be a lot of these are I'm honored to be with the top practitioners, pioneers of big data and Hadoop. So there will be a lot of opportunity to find out about what is working, what's not working, where are things breaking from these folks. So with that, maybe what I'll do is pass the mic along and just introduce yourself.
Hi, my name is Charles Zaleski and I work at Cloudera.
Hi, it's Todd Papuanu. I'm an entrepreneur in residence at Battery Ventures.
Hi, my name is Anmol. I work at LinkedIn with an analytics team.
Let's test these mics. So I'm a little worried now. I'm not cool, nor am I a nerd. So I don't know if I belong. But my name is Karthik. I work for TiE. We are a big data analytics company in stealth mode.
Hi, my name is Dhruva. I'm an engineer currently work at Facebook. I'm working on big data stuff. I've worked at Yahoo before. I started doing Hadoop stuff kind of very early on. So very technical person. There's some technical questions.
I think everyone knows who Facebook and LinkedIn are. Do you want to just tell us a little bit, the three of you, what your companies do?
Sure. Cloudera is an enterprise software company. We're about 3 years old. We're a company that was founded entirely dedicated to the idea that Hadoop was going to represent something exciting for businesses when it came to data management. We see Hadoop as this big open platform for companies to solve all kinds of data problems, and we provided an open source distribution of that system.
Battery Ventures is a multi-stage investment firm, been around for a long time. Been investing in kind of like infrastructure, digital media, so some of our investments would be things you might have heard of, like NetEase, Akamai, people like that, Groupon. My background is, like I said, I've been doing big data before big data even became a term. So I was previously at Yahoo as the chief cloud architect there. I was responsible for technology and strategy. Before that, I was at Teradata for 5 years as a VP there, and before that, I was chief architect at Greenplum.
I'm skipping this one. So can't say much about CETUS. We are still in stealth mode. Visit cetus.net and register and you'll learn more. But just to give you a bit of a background as to why we even created the company, we've been thinking about big data for a couple of years now. Not as long as some of the guys here, but certainly for a few years. And I had a company before as well which dealt with a lot of data. Hundreds of millions of rows was frequent. And I think that whole term has taken new shape now, as we find more and more online companies with more of us generating content, which is becoming relevant. It's not just content that's sitting out there, relevant content. So now it's taking shape, so we're glad to be in the space at this time. We'll share more about the company itself, hopefully in the coming months.
So let's get started. And so this is the space around data warehousing and business intelligence has been around for quite some time. And so there is a reason why there's a lot of focus on new technologies, new approaches, new processes. So maybe we can go down and kind of pinpoint sort of one or two reasons each as to what is it that those technologies could not do that we're looking for.
So I probably have to answer that question almost every week, because that's always what our customers want to know from us. Why should they consider taking some new kind of technology into their environment? They've already bought all this stuff. My thinking is that for any enterprise to want to adopt something new, whatever it is they get proposed should be 10 times better than whatever it is they have today. Because if it's only 2 times better, I like it okay, I'm familiar with it, there's just not enough motivation to switch. And having seen this enough, I've distilled it down that I think the 3 things that Hadoop is 10x better, and this is why people keep coming back. I'll do them in sort of descending or ascending order of importance. One is it scales really well. So the larger Hadoop deployments today are, Facebook has the single largest one by terabytes under management at about, I think, 25 petabytes. Yahoo, in terms of node count, is around 4,000 for a single instance. And it does that scaling really without a lot of stress, which is the other thing. So you can get some systems to scale out to a petabyte, but that's typically when they bring in the people with the protractors and the welding masks and Hadoop, that you can actually get out to a petabyte without that same level of discomfort. The second thing that it's 10x better at is it's really cheap. So the all-in cost per terabyte under management, when you factor in software, hardware, if you pick a vendor like a Cloudera to support you, if you roll all that in, you still wind up roughly about 1/10 of the all-in cost under management of a traditional data warehouse. If you compare it to that, you probably wind up with about 1/3 the cost, even when you could just contrast it with raw storage. So you're coming out ahead next to almost anything else you compare it to. And that you'd think that would mean that we're not going to earn a good living as a company, but it turns out that when you have a really cheap way of holding on to data, you just hold on to more data. Like it all nets itself out. But the most profound difference that Hadoop really represents is actually, you can ignore those other two things. The biggest thing it actually represents is flexibility. So the real charm of Hadoop is the idea of bringing data processing to storage. And the idea that you can throw a bunch of data in a system that's disorganized, that could have no schema, no structure, and you can still analyze it after the fact. And that's a profound difference relative to what you do with the database. And it's the fundamental departure for Hadoop. The ability to hold on to data and worry about structuring it later, or the ability to change a schema down the road as you discover new facts, that winds up opening up a whole bunch of use cases that weren't previously possible.
Yeah, I think just to kind of like pick up on that point, I think for me, cost, scalability, I think you can't argue about scalability. The cost, I think you can argue about, but for me, the big difference is the type of applications you can build. The type of applications that you build on a traditional RDBMS are well-known, highly structured. You know the relations, you know the questions you want to ask. The type of applications that you build on a big data platform, and Hadoop being the most prevalent one, are much more, data discovery, data mining, or changeable type of applications. And so the way I see it is, it's a very complementary technology stack to your existing EDW or data warehousing stack. And we're seeing a whole new raft of applications that didn't exist before start to spring up, in front of us and around us.
So I think I'll second that. Basically, the kind of applications that Hadoop has enabled, especially at companies like LinkedIn or Facebook, and even other e-commerce companies, where sort of petabytes of data is being generated almost on a daily basis, and what can you do to process the data in a reasonable amount of time and turn it around to get real actionable intelligence or business value, which was just not possible maybe a couple of years ago.
So I agree with everything that you said. I'd like to add an example perhaps. So we've been talking to a number of online companies, and what's going on there as a trend is they have millions of people using their apps depending on who you talk to. You talk to Zynga, they have millions of people. A small gaming company in San Francisco that we talk to has about 1 million users of one of their popular games every single day. See, that's the kind of scale we haven't seen, say, 5 years ago, right? And all of that is material information. For example, the gaming company needs to know exactly what their users are doing so they can enhance the user experience, retain more people, sell more virtual goods, be able to advertise better. So all of this activity is not just activity, it's important activity that if mined correctly can give you significant competitive advantage. So that's what's gone on. So it's not just the sheer size of data, it's the speed in which it's being generated and the relative relevance of all of this data. This is not data you want to throw away. So this is all what is contributing to the need for a new way to look at managing this data. The traditional enterprise solutions, BI solutions, and data warehouse technologies, I started off as a data warehouse programmer in the 90s, and nothing has changed since then. It's the same SQL. There are bigger machines, but nothing's practically changed. And meanwhile, we've gone through the internet revolution, and Web 1.0 and Web 2.0, storage has gone up, everything's gone up, but somehow the BI technologies have stayed behind. Hence, it's of real importance that we all adopt what needs to be adopted for the newer apps. So hence, the importance.
Yeah, I have a little bit to add here. So when somebody's asking me what is big data, I like to kind of explain it in more measurable terms. So for us, for example, big data means we produce around 40 terabytes of data per day. So the total size of one of our clusters is like 70 petabytes now. So if you want to run a query on a 70 petabyte warehouse, that is on the extreme case of big data. They're even smaller than that, but this is kind of the outer limits. And then another thing I think I'd like to mention that why Hadoop is good at, or why big data has been so popular, is because it is being driven by a software called Hadoop, and that is open source. Unlike many other technologies where there is no such open source technology for people to play with. So that has been another big driver why big data has become suddenly taken off and everybody's starting to use it. Just because there's an open source alternative for people to play around with. I think that's very important to kind of understand ourselves that why is this area taking off so fast? Existence of Hadoop.
I didn't hear any of you mention kind of two things. One is sort of the explosion of unstructured, semi-structured information, which traditional data warehouses have not dealt with. They've dealt with structured. And the second is sort of this whole ETL process, extract, transfer, load, which is a very heavy process. People want information and insights at their fingertips.
Yeah, I completely agree. I think also just because it's an open source model and you can put in a lot of data, that means a lot of different people in your company or in your organization is putting data. So more people are invested in your warehouse. Traditional warehouses, maybe only like 10 people get access to the traditional warehouse. Whereas if you have a Hadoop warehouse, the psychology of persons in that place is that everybody can run a query. So that actually is a global kind of democracy as far as data is concerned. Everybody in your company kind of runs queries. It's not like a traditional warehouse where it's all walled off garden.
I heard, Dhruva, you kind of you defined big data in terms of size and volume. Does someone want to sort of add what do you think
I mean, I think scale is part of it, right? I think that's, scale is why the name big data arose, right? But it's not everything. I mean, I think, when you look at the actual data, other people might call it new data or unstructured data or multi-structured data. I think the type of data that's being generated has been around for a while, but people used to have to take, 6 to 9 months doing a kind of data modeling exercise to build the data modeling schema for their EDW and then the data cleansing and the MDM and all the rest of the bollocks that goes along with it. I think that what people are finding now is actually time to insight and value is the most important thing for the business. So what they really want is they just want a platform that they can just pour data into and start to get value insight out of it. And traditionally this unstructured data or big data is data that companies have not known what the value is in it, what the insight is in it, so they just used to throw it on the floor because they were like, I don't know what the value is, so I can't justify putting it in a top-end data mart, or top-end data warehouse. So they threw it away. Now with Hadoop and the rest of the NoSQL databases, you're finding that the dollar cost for the platform is low. You can just pour it in and extract value out of it, immediately. And so that's, I think, why this kind of whole new market is being built around us.
Yeah, I think schema is the main thing that I would use as the defining axis. So yes, it's true. Like Hadoop can deal with text and with images, but also it can do transactional data. But the most important thing is that it can be dirty. It can have missing. It can have gaps. It cannot have a primary key. It can have no schema. It can have no data types. It can have none of that, and you can assert it all down the line. And I remember when I was being recruited by Cloudera, and I didn't know much about this world at all, and taking an educated, and at the time it was not that adopted. My only educated guess as to why I thought it would go somewhere is I knew from my prior life in software company how much customers spent on these architects that designed star schemas for data warehouses, and I knew just how much time and money was sunk in that exercise. And if that goes away, I know there's something worth doing here.
Ravi, another dimension, and I'm glad you brought up the question, because big data is not just about the scale, the volume, it's some of the other elements that these guys have mentioned. Another dimension that I'd like to add to that is the dynamicity of your business too. The rate of change that's happening in your application is key. So big data is about how well you can capture the changes that you make in your app today and the effect it has on your user population tomorrow. Well, the same day, in fact. So, take the same gaming example. If I make a change to the game today, can I see the effects of what the game did to my user base right away? Do I have to go back and alter my table space and wait for 3 days before the database can be changed? so all the data can be captured and a BI tool can get it out for you in the form of a report. No, I'd rather see it instantly. So that dimension of the rate of change of your application being able to be accommodated in your big data infrastructure is key.
So the technology that is most commonly, as Dhruva was mentioning, associated with big data is Hadoop. And Hadoop is a sort of a whole stack with origins from Google and a number of the companies from the gentleman here. So I asked Charles if he would kind of give us a 3-4 minute history of Hadoop and talk a little bit about the components.
So Hadoop
You
is.
can get through this without the logo appearing.
Yeah, Hadoop has got so Hadoop's had a lot of success, and they say success has 1,000 parents. So hopefully I do all the parents justice. The origins of Hadoop, I think by most people's reckoning, is Google. So there's when Google got started, their main use case initially was I want to index the web, and they said, okay, how many web pages are there? I don't know, 4 or 5 billion. How much? How big are they? A couple kilobytes. They're pretty bulky compared to records. So I got to store all of that data. So they started by designing a file system that could scale out horizontally. They didn't have much money either, so they needed to work in commodity hardware, and they couldn't call up EMC and see how much like the latest symmetrics would run them. And then they had to turn all those web pages into a search index. So they needed some way of processing the data. And you think about a web page. There's some structured data in there. There's like IP address, URL you might consider somewhat structured, but there's also lots of stuff which is totally unstructured. There's images, there's text snippets throughout, and all of that could be potentially relevant. So running SQL against a web page didn't make any sense. They came up with this framework called MapReduce, which was a kind of a very flexible data processing primitive that could allow you to transform this kind of data or to analyze it. These two things were being worked on around about 2001. There was a paper written on them, both of them somewhere around 2003 or 2004. That eventually became the germination of the design for open source Hadoop. But they kept going. They needed to find lots of different ways of ingesting data into the system. So you not just have to store lots of data, but suck it in at a fast rate. So they built some frameworks for that. One of the ones that got a lot of attention was, I don't just want to store files. They were storing like big 64 megabyte files to rummage through. But I want to be able to manipulate records and tables, not just files. It's more convenient for some things. So I don't need a wood chipper, I need a Ginsu knife too. So they built this thing called Bigtable, which was all the same scaling properties of file storage, but applied to tables and records. And then they said, well, MapReduce is so low level, and you have to be able to code and code at a relatively low level. So they started creating high level languages. So you can think of MapReduce like assembly, right? So someone needed to create like the Java for MapReduce. So they created a number of these different high level languages. Sawzall was just one example. And then they said, well, these data processing pipelines, they're getting more complicated. I need to start to chain together more complex workloads, complex graphs, interdependent jobs. So they built some of the frameworks to do that. They need to be able to schedule things. Then they also said, well, end users want to be able to query this stuff conveniently. Columnar layout tends to be a way that you can do it much more quickly. Users don't want to understand data types. They just want to see tables. So they built a metadata framework they could overlay on top of the raw storage. And then they created a query engine that then end users could use to access it. The analysts could get ad hoc access. And there's a little bit of narrative liberties I took with this story. And the Google story didn't end there, by the way. Like, if you want to study where Google's gone, there's things like Borg and Pregel, and many of these systems are already on their second and third generation. But this gives you a little bit of an idea of the origin. Now, if you look at some of the early adopters of Hadoop, they're all here on the stage today. So one such adopter was Facebook. They also needed some distributed locks. They built this thing called Chubby. So. Meanwhile, if you look at Facebook today, you see the same picture. The names in the boxes are different, but they're largely playing the same role. I'm missing a few things from the Facebook picture, which are not public record, but all of this is public record. And if you look at Yahoo, you'll see the same system. They've built different components in some cases for different reasons. Same story for LinkedIn. You'll see the same system. They built different components for different reasons. So across all of these things, and then if you see Cloudera, so we make an open source distribution, so you'll see some things the same, some things different. Yeah. So all of these things are open, or almost all of these things, I should say, are open source. In many cases, different organizations share the R&D cost of these as parts of open source projects. In some cases, folks have chosen to go their own way for whatever technical reasons or business reasons. But what I think you should think about is that so there's all these unique strengths of Hadoop, but what's really being built is this big distributed operating system for processing and analyzing data. And the pattern keeps showing up again and again and again. And I think, so at Cloudera, our mental model for this system is a little bit like Linux. And it's tough because when Linux came onto the scene, everyone knew what Linux was supposed to be because everyone could look at Solaris and AIX and HPUX and say, oh yeah, that's what an operating system looks like. And I think with big data, it's harder for people to visualize because they've never seen this reference system before. But it's there, like the pattern is there and it keeps coming again and again. And it looks something like this, or like that, or like that, or like that. So that's what we're running today. We're building more. It's going to get even more gnarlier. There'll be more boxes on this page in 12 months than there is now. But this is roughly the state of the union.
So what I want to do. What I want to do now is maybe go to the gentleman on the other side and talk a little bit about, there's this whole promise of big data, and kind of let's kind of narrow down sort of the use cases. And there's some great examples with the gentleman on the right. How do you see your organizations using big data in various ways? What is it doing for your business? And then maybe on a broader level, how do other online businesses and how do enterprises use big data? Yeah.
So thank you for bringing up this slide, because I think this is one of the kind of key highlights that I wanted to bring up, and when we talk about big data, and with the advent of social networking, or I call it professional networking. I work at LinkedIn, right? And isn't that what TiE is about as well? So, right context. Well, so essentially, we have 120 million members spanning 200 countries, 140 different industries, and I think about 2-some million companies have registered records on LinkedIn. And so what this opens up is a data space that essentially has front and center. What it has done is brought business opportunity front and center in this burgeoning internet space. So one of the applications that Ravi put together here was we wanted to figure out a way of how you could look at your professional network and try to figure out how do I categorize the nodes in my network to leverage my connections to various organizations for economic/career/business opportunities. So one of the things that we had to do in this particular case was to take about the 2.6 billion connections in our social graph and try to algorithmically assign sort of clusters that you could see forming. So one of the applications that you could potentially think of in this scenario is how would, let's say you have a new product that you want to launch, right? So you are trying to identify the viral nodes in your network, which could potentially be targeted to push this product to. And then how does that information start to circulate in their professional networks going forward? So this is one example which uses Hadoop pretty extensively, because essentially if you think about analyzing 2.6 billion edges of a graph and running graph mining algorithms, which are basically iterative in nature. When we talked about the traditional SQL kind of technologies, we were talking about at least a couple of weeks to get this kind of analysis, which we run less than a day now. On on a not such a big cluster of Hadoop nodes. So if you could click over to the next one. Another one of these cases, I mean, I think, LinkedIn is all about economic opportunity, creating economic opportunity for our members. And one of the things that people love LinkedIn for, well, recruiters love LinkedIn because they find this incredible pool of talent in our member base. And so their primary objective is to find folks whom they can handpick and choose to figure out, okay, I have this phenomenal job opening, I just want to hire this particular person. Well, how do I go about doing that? Well, there are multiple kinds of analysis that we have done on this kind of data anonymously. But, so I brought up one very cool example in which we were trying to sort of understand if we were to build a product which said, well, I come up with a job description, now you find me a bunch of folks that sort of fit my job description. And that's a very easy, I shouldn't say easy, okay, that's a well understood sort of content matching problem that is classical recommendation systems usually deal with. Now the problem is, well, this guy already has a fantastic job, so what do I do with that? Right? So for enabling this particular product, what we did was we started to look at career transitions of how people have been moving multiple companies across the board. And then we also sliced and diced it by industry, by geographical locations, and so on and so forth. And so the aspect of big data here is that we have about 2-some billion position records for folks and their transition paths. So think about 120 million members and 2.6, I don't know what the exact number is, but 2-some billion position records that we've accumulated for these members. And if you start to analyze the patterns of how these people are switching jobs, one of the cool things we started to observe, well, if you start looking at the number of folks in your professional network who have quit your particular company in, let's say, 6 months, then or X number of months, I can come up with a confidence measure of saying, yes, you are about to leave because of the fact. And it's about this is not an anecdotal story. This is what the data tells you. And so if you think about the scale that we've analyzed here, to get to something like this is another one of those unique cases where Hadoop has played a pivotal role of coming up with actionable intelligence.
Without revealing any secrets, anything, I'm always mystified, surprised, and sometimes shocked by sort of the recommendations for friends you make on the right-hand side. Any very high-level...
So actually, I was already expecting that question, so I have a canned answer for that. No, just kidding. So actually, the product is called People You May Know. In fact, majority of the social networks have adopted People You May Know. However, LinkedIn was the first one to do it. Obviously, when we started off, we didn't have enough members, so we could just run it off SQL scripts, and it just run maybe in a couple of hours on somebody's desktop on his desk, and it just worked just fine. And so happened that our membership growth sort of surged, our connection rate sort of surged. People started putting a lot of content on their profiles. LinkedIn, had arrived. So we had to come up with alternative measures of trying to figure out how do we provide a product that really drives value for an individual in the professional context. One of the key things that we realized, and I think that's the basis of the company as well, that your professional connections are the most important factor when it comes to professional success, especially in this internet network world. So PYMK started, means people may know, started off as a hack day project. Somebody thought, well, it's a cool thing to do. Let's run a graph mining algorithm on our graph, which at that point in time was maybe, I think 5 million nodes, and the number of edges were roughly about 14, 15 million. It was possible. And it so turned out that as the data that we started to collect for our members grew, their activity, what the kind of companies that they worked at, the kind of schools that they've attended, with the timestamps of where, they say, well, I worked at XYZ company during this year to this year, so that kind of starts to give signals around how you could possibly know someone, educational backgrounds, graph mining with respect to the fact that you are connected to person X, who's further connected to person Y, and so you are connected to Y. You're not connected to Y, so but Y is a very valid candidate for you, potentially. And if there are a lot of these X's in the middle, then on account of the common paths that connect you to Y, that's a very strong signal. So we essentially have roughly about, I shouldn't give you the exact number, but let's say about 40 to 50 different signals that we interpret on almost a daily basis to come up with these recommendations. And the additional part I wanted to add was when we kicked it off, we had a very small, 10-node Hadoop cluster as an experimental cluster, and it used to take about a week to churn through the graph. With significant investments that the company made in Hadoop, we can now turn it around in about less than a day, which is still something that we are actually trying to bring down further. But that's where we're at.
Ravi, just a quick addition to that, and I'll hand it to Dhruva. So this year, by the way, is the meat of the discussion, the use cases behind big data, and we haven't used the word much in the context, but analytics is really what we are doing here, right? I mean, this is what is leading to making conclusions, making decisions. So analyze the data. How are we going to analyze the data? By collecting all of this data, which is big, and being able to put it into infrastructures that render themselves easier to analyze and query. So a use case, for example, the way our product helps an online company, and I'll take a different example this time, say an e-commerce company. There's a couple of different ways in which they benefit from analyzing all of the big data that they have in real time. Hundreds of millions of people visit, say, Sears.com, and what they need to know out of that is what the user behavior was, so they can make adjustments to the categories in which they display items, as a small example. So placement of items on the website matters hugely, and the only way in which you can make significant effects to it to increase your revenue is going to be by understanding the user behavior that is leading to transactions. So if you can create a funnel of how your users are moving and in what sequence, then you are able to better place your products for higher revenue. That's a use case. A second use case Anmol referred to is really the recommendations engine, which we all know some of these companies like Amazon in the e-commerce space are really good at. If you read this book, you probably would like this book too. That's great. It's not random. It's this whole science behind it. The third use case that we found talking to ad publishing companies is placement of ads. So if you are running a website where advertising revenue is huge, you have to know what your user population is doing, and you have to do whatever you can to retain them, because the only way in which you can increase your advertising dollars is going to be by showing a higher revenue base and an increased retention time on your website. Right? So these are some very popular common sense use cases, but there's a whole science behind it, and only big data analytics can help you do that.
Facebook has 800 million people, and everyone's updating their status all the time, and you have like buttons all over the place outside of Facebook. This is a kind of a scale of data-driven company that outside of Google we haven't seen before.
So yeah, I agree. Just to back up a little bit, I think just to give a little bit different perspective of the history, I think we should also acknowledge the amount of investment and execution that Yahoo has put in. Although Google came up with the idea, they didn't supply even one bit of code. So all the code, all the execution has been done by people outside of Google. And then for Facebook, we adopted a very different strategy from other previous generation companies. I think all of our code is open source. So Hadoop plays in that area. And the way we use Hadoop is kind of few things. Most of them are already mentioned: recommendation systems and advertisement. So that's our basic bread earner. In the sense, we need to show the right advertisement to the right person. So to show the right advertisement, we have to mine lots of data to figure out whether the advertisement that they show you is the right advertisement for you or not. Because we want people to actually like these advertisements, and somehow increase their sharing rate and the amount of information that they're getting. We also use it for sensory data. So when you do like things like likes, the like button is kind of a sensory data in that sense. You could compare it to like it's a sensor generating data automatically, right? And then we have lots of these. So we do analytics on these. So analytics is definitely one portion where we use, but then we also use big data not for analytics, but also for storing, say, Facebook messages. So all the messages that you send from one another, like my email address is dhruba@facebook.com. So if somebody sends me an email, that'll be stored in a big data platform. We have something called HBase. So that's not an analytics platform, but that's more like a real-time serving platform. But the amount of data is so big that it's a big data system.
And I just want to carry on with a couple of examples because I think analytics is a big part of the workload for sure. But I think picking up on what Dhruba was saying, at Yahoo, I'm going to put my Yahoo hat back on now. It's been that long, right? It's only a couple of months ago since I was there. Advertising optimization was certainly one thing that we did, but we also focused on content optimization. So for Yahoo, the goal was, can you deliver the most relevant, compelling experience, right, of content and advertising? And so when you came to one of our pages, we weren't only trying to show you the best ad, we're also trying to show you the best piece of content, the best news article or sports thing or travel or whatever it was, right? And putting those two things together. And so, I don't really call that analytics per se. I call that, like a data application. Right? And we used to have a bunch of other apps like spam filtering, for example, which is not really traditionally analytics, but it's more like modeling and scoring and building, those types of models. And we used to do that all on Hadoop. Right? So I think analytics is how, the traditional set of companies are starting to look at Hadoop as a platform to do low-cost analytics on. But once you get beyond that and you start to see where the leading-edge companies are, like Yahoo and Facebook and LinkedIn, they're beyond that now. They're actually into this kind of like new next generation of data applications. And I think that's what we're starting to see kind of like being built up. And what I think is really interesting about this space.
What about traditional enterprises? We've heard a lot of online use cases. What about the brick and mortar companies?
Sure. So surprisingly, these patterns just repeat themselves. So it's actually a lot of it just gets mystified in the terminology, but you actually find these things in regular industries too. So at Cloudera, like our principal customer base is telecommunications firms, banks, retailers, media companies, and these things come again and again. The generic terms I throw at it, one is what I call like advanced analytics, meaning any kind of like pattern model building. So whether it's like who's going to like this ad, who's going to want to look at this, read this article, all this kind of preference anticipation stuff tends to be in Hadoop. And then the other one is data processing. So by the time you got to the data that you use to discern, who's friends with who or who wants to see what, you typically started with much dirtier, messier, difficult to work with data. So typically what happens in Hadoop is you land all this stuff in it, it's all in disarray, and then you have these automated pipelines which pick it up, trigger off new data, and through, maybe they may go 100 steps deep, they turn it into this summarized stuff, which eventually the machine learning model, the preference model gets built off of. And so now, back to your point of regular industries. Retailer. So retailer will store. So there's famous stories of retailers, which is like they can predict stockouts based on the weather and stuff like that. They care about how much they have in their shelves. That's all true. You can do that in a regular database. This retailer is going to store, has stored every cash register action from every lane from every store going back for 15 years, and they can do just from the sheer volume they can do worthwhile things like certain tax holidays that only show up at every couple of years. They can actually now predict what happens when a tax holiday, what that's going to do to lift in sales, and they can plan inventory. But more interestingly is they can do basket of goods analysis. So they can say, well, I've got 100 different product categories, and really I don't just want to know how many Pop-Tarts are purchased in Des Moines. What I want to be able to ask questions like, in Des Moines, people that buy Weber grills also tend to buy shotgun shells. So I want to make sure that I grow my inventory that proportionally. Or I know that whoever buys shotgun shells, I want to have a coupon ready for them at checkout to go buy a Weber grill, right? So like a traditional data warehouse can actually scale to petabyte of data. And if you want to do like what was sales last month, like you can do that in a database with enough money. But if you want to say take all that petabyte and multiply, 5,000 stores by 100 product categories, by 100 product categories to create all these different basket of goods, and then go figure out who's actually buying what and correlate that, that just brings a traditional system to its knees.
I'm going to have to take a slight little to task of that last comment. So I think that's definitely fair, right? But there are traditional platforms out there that will scale way beyond a petabyte and do all of that. I think the difference is that, and there's a number of vendors out there who sell, very good quality products, been around for years. The difference is that the only questions you can ask in that scenario are the ones that you already thought of, because that's the schema that you laid down. Right? So, I know there's traditional vendors out there doing 1,024 petabytes in a platform. Right? That's huge. But I think that why this new platform is taking off is because you said, oh, well, I thought of 20 questions, right? And I laid the schema out to that. Now in the new big data platforms, you can say, oh, but there's the next 20 questions. I can ask them today. I don't have to wait 6 months to kind of like do the remodeling. So this is where I think, not only the cost and the scalability, but the flexibility of the questions that you can ask that, we're starting to see this kind of like big data really take off.
Go ahead, Dhruv.
Yeah, I have another perspective there. I think, although you say that there are a lot of other companies who can process maybe like many better